Hello, welcome to our webinar today, which is all about sizing heat pumps with real-world heat loss measurement. So thank you for taking the time out to join us. I hope you enjoyed the presentation. I would ask that everyone can remain muted throughout the call. There will be a chance for questions at the end, so we can unmute you then for questions. If you have anything in the meantime you want to post, you pop it in the chat box and we will get towards that at the end. So to introduce myself, I'm Lucy Cowell and I'm the Client Relationship Manager here at Veritherm. I'll also be joined later on by my colleague Tom Fenton, who's the CEO, and he's going to show us some of the reporting side of things. We're delighted that we're also joined today by our guest speaker, who's Nathan Gambling. He's host of the BetaTalk Renewable Energy Podcast. He's an expert on heating systems and an advocate of using real-world measurement calculations over modelling and desk-based assumptions and assessments. So we've worked with Nathan on projects in the past for heat pump installations, and he'll be providing more detail about those. So just to explain a little bit about Veritherm and what we do as a company and the services we provide. We've spent the last few years working with specialists who've helped us develop our technology to get to the point where we're now world leaders in building performance evaluation. So that's about, rather than relying on design predictions, we can now give actual data about how well a building is functioning. And what we're best known for, and what you may know about, is our breakthrough technology, which is an innovative and unique thermal performance testing solution. I'll be talking about that a little bit later. And that's a service that we're now able to make available to clients throughout our network of delivery partners. So just to show you some of the delivery partners we have, we've got the whole of the UK covered. So wherever you are in the UK, we can now provide Veritherm testing services through our network of partners. And these are all engineers that we've trained up to carry out Veritherm testing. So just to talk you through some of our solutions. First of all, we have Veritherm testing. So this is a thermal performance test which can measure and verify the heat that is lost through the fabric of a building. It takes just a single night, and the data it provides means you don't have to rely on assumptions about how well a building is performing, as you're provided with instant and actual real-world measurements. Then we have Veritherm monitoring, and this is something we're currently developing and we're introducing to the market later this year. This will be about understanding energy use and heat loss over a period of time, so when the occupant is in place. And we'll be looking at both of these in a bit more depth later on and explaining how the testing and monitoring processes work. And just to let you know, also another thing we're doing at the end of the year is we're looking at adding Veritherm industrial, so testing for industrial and commercial units from 250 to 5,000 square metres. That'll work in a similar way to the domestic side of things, but it'll be using scaled up industrial size heaters and fans. So obviously they're very large energy consumers, with units running 365 days a year. So there's massive savings to be had by improving their thermal efficiency. And that service will include a level 2 air tightness test and a visual inspection of the thermal envelope alongside the drone thermographic equipment and a Veritherm test as well. So take you through a few of our services that we're currently offering. So we've got a range of services to complement the Veritherm tests. So when you put these together, they create a really good package of measures. So we can look at energy modelling, so things like SUP assessments. We're also doing other testing such as air tightness thermography and acoustics, monitoring of indoor air quality. And like I say, when you put a combination of these together, we can create a bespoke package which gives a full health check for a building based on the client requirements. We're also moving into consultancy and helping clients who want to concentrate on getting the fabric of their building right before incorporating renewables. So by getting that right will mean that heating system requirements might even be smaller. We can also offer retrofit advice as well, and research support. So looking at bespoke case studies for industry professionals such as heating engineers, heat pump manufacturers, or even developers who might want to know how well heating systems are working across other building archetypes. So all these mean that we're now sort of a really good one-stop shop for anyone that's wanting building performance services. So it's a good time to be in the heat pump business, I think. It looks like there's busy times ahead for everyone, partly due to the UK government's Green Recovery Plan. So this will prove there's going to be massive demand with their target of 600,000 heat pump installations per year by 2028. So with such demand, it's going to be really important to size appropriately so that customers aren't being overcharged and making sure they're getting a system that's going to deliver enough heat for the occupant needs. So other drivers and funding that's out there causing demand is the Social Housing Decarbonisation Fund. There's £160 million of funding, which is just in wave 1, which takes us to 2023. And just looking at that graph there, you can see that of approximately 24 million homes in England alone, there's about 4 million which are social housing. And within that, 1.6 million are below band C of the EPC rating. So there's a lot of buildings out there that aren't performing and will be using this funding to try and improve the efficiency of their home through such measures such as installing heat pumps. There's also the electrification of heat demonstration project going on, and that's a feasibility study for the large-scale rollout of heat pumps. Funding there's over 14 million at the moment. It's been made available. So that's aiming to demonstrate the feasibility of a large-scale rollout by installing heat pumps in a representative range of about 750 homes, for then hopefully rolling out on a much wider scale. So I'll now just hand you over to Nathan, and he can talk you through some examples of using measurements in heat pump installation.
So my name is Nathan Gambling. I'm the host of a podcast called BetaTalk, and what I wanted to do with that podcast was disseminate the voice of an engineer. Any of you involved in the heating industry have probably realised that the whole world is now talking about the heating industry, and obviously we've got this thing about renewables. And so I wanted to do with my podcast was to make sure engineers had a voice, because there's some fantastic engineers out there. Not all the engineers out there are great. And with renewables, and especially with heat pumps, you do have to get the design right. So today I'm joined by two of my regular guests that I feature on the podcast. On my right is Adam. Adam runs something called Heat Geek. He's one of my leading experts. He's one of the UK's leading experts in teaching people hydronic design. So for argument's sake, for the last 3 sort of decades, we probably have come away from knowing a lot about hydronic design. The boiler industry, rightly or wrongly, made it very easy for us to just stick boilers on the wall and not go too much into the design of a heating system. System being the operative word. Heating is a system. It's not your heat source. It's not your boiler or your heat pump. It's the system, and you have to get that design right. I'm also joined on my left by Steve from EGE. EGE, isn't it? So EGE, based in Norfolk, near where I grew up, and Steve's been involved in installing heat pumps for over 15 years. So we're going to be able to answer any questions at the end. So getting the size of a heat pump is quite critical. Getting the size of a boiler is actually quite critical. It's just that most of them are made far too large for what they need to do. And historically, we used to do that back in my day and Steve's day with the Mears calculator or longhand. We used to do our calculations to work out how much energy a property needed. That's not really done anymore. That you don't find lots of people actually do that anymore. It's starting to come back, but obviously with heat pump installations, you do need to get that design and work out what your home needs. Now you can either calculate it, or like what Veritherm have come up with, you can actually measure it. And that's what I really like, the fact that you can get a real accurate idea of what your home needs. And if you're not in the industry, I mean, I don't know what the audience is, but if you're not familiar with how we design a heat system, what we tend to do is design it to a design temperature. And design temperature means is the average coldest day in the winter. It's not the coldest every day it's going to happen, but it's going to be the average coldest day. And that's usually -3 in the UK. So what we need to do is design a system that can provide enough heat when it's -3. Now, for those of you who know, heat is measured in joules. And so we need a certain amount of heat per second, and that's your watt. So a joule per second is watt. So we need to know how much power we need for that room or that home to be able to match the demand, because heat is always moving. Heat always wants to travel. It wants to equalize. So we've got air in our home at around 21. That's what we designed the air to be, 21. If it's -3 outside, that heat energy is trying to move outside. And it's a bit like a seesaw. If you put a football on a seesaw and you raise it up, so this is a bit higher, the ball will move quickly. And it's exactly the same with heat. Heat will move quicker from indoors to outside if it's colder. So if it's only 10 degrees outside, the heat doesn't want to move as quick as if it was -3. So we need to know what our energy demand is, what that power is we need to put in. If it's a 6 kilowatt, if we've found out that it's 6 kilowatts at -3, that means we need 6,000 joules per second of energy going into that home to maintain our level of comfort. So getting that heat pump sized properly is quite important. Now, if we have got a 6 kilowatt demand at -3, it doesn't mean we go out and rush out and buy a 6 kilowatt heat pump. Steve will probably answer some questions on that a little bit later, because we have to look at the tables. Each manufacturer will produce tables of what their machine can do at given temperatures, and it won't be that -3. So you have to then work out and size it quite correctly. There will be problems if you oversize, and there'll be problems we can discuss if you undersize. So we want to get it quite exact. Like I say, we haven't really been doing that with the boilers. Most boilers, many boilers now are your combi boilers, and we tend to size them for hot water demand. So they're 4 times the size of what your home needs actually for heat. Even though we have got a leaky housing stock in this country compared to Europe, it's quite surprising how much little energy you need compared to that badged up boiler. So boilers, what, 24, 30 kilowatt. Many homes in the UK only need 6 kilowatts at that design temperature. The bigger they are, obviously, they're going to need more energy. But you'll find that your heat pumps are going to be a lot smaller sized than what the average boiler is going in. So it's very critical we get that size right. The design is then factored in, and we want to design flow temperatures. So Adam on the right will design as low as he possibly can. I mean, we even know people don't design at 35-degree flow rate, because the lower you can get your flow temperatures running around your radiators, so the lower that temperature to outside, the closer the outside temperature is to the flow, the more efficient your heat pump's going to be. So the sink and the source, the closer you can get the sink and the source temperatures together, the more efficient your heat pump's going to be. Now, I think Tom is going to show an example of a home we surveyed. So I'm lucky enough to know a few people, and one of the special advisors to 2 of our energy secretaries got hold of me, and he wanted a heat pump, and so we got Veritherm to go in and do a proper measurement. Normally, like I say, we do a calculation. There's some good calculation software out there. The trouble is with calculation is it's open to sort of lots of interpretation, and it can sometimes be quite way out. It's still worth doing, and a lot of people still do the calculation, and then they'll go in and do the proper measurement as well. And I think Tom is going to show us some slides maybe of a job we did for Guy.
Thanks, Nathan. Yeah, we'll pick up from here, and Lucy will give you a bit of a rundown about the technologies that we've got on offer. So a bit more of a deep dive into Veritherm testing and how it functions. And then, like you say, I will run through some case studies, giving some examples of that particular property that we've tested and some others, so that you can understand, you know, what limitations we have when we're using kind of desktop and, hand calculations to size and balance heating systems. So hopefully that will give you some insight into how real world measurement is going to help us transition to a lower carbon economy, as well as more accurately size and balance heat pumps that we're looking to retrofit and install on new properties as well. So Lucy, I'll hand back to you, and what we'll do is we will move on to our second part of the presentation.
So for the second part of our presentation, I'll just take you through a bit more about the Veritherm actual testing process. So what's involved in actually carrying out a Veritherm test. So the first part is all about preparation. It's divided into 3 stages. So the preparation stage is when you'd have an unoccupied property. You would get some preliminary calculations, which you might take from a SAP worksheet, for example, and you would go to the property once entering your calculations into our platform software. Once in the property, you would place up the equipment, which would be a combination of fans, heaters and temperature loggers. So these are all attached to smart plugs, which is what enables the test to start remotely. The idea is that the fans send the heat around the building, so the air will be circulated throughout the building for the first 6 hours of the test. When these are switched off, the second half of the test, the heat dissipates throughout the building. It's at this point that the measurements take place. The temperature logger is also outside, so you can tell the differential between outside and inside temperature. So in that measurement stage, the temperature is being calculated right throughout the night. It's being recorded in real time on our platform, so engineers can look at the data from the comfort of their desks, and also provides instant reporting later on. So when it comes to the calculations, these produce a range of heat loss coefficients for the building, and this can also give you a measurement against the building's design data, so how well it's performing against how well it's actually designed to perform. This means you can also then sort of size heat systems accordingly, as Nathan's spoken about and Tom will show you a bit more about later as well. Okay, so why might you use Veritherm testing? Well, with Veritherm testing, the occupants don't influence the behaviour because there's no occupants at home. It's just an accurate measure of the building performance itself. So you're not getting heat that's generated by cooking or electrical devices or opening windows that are interfering with the test results. So it's a true test of heat loss through the fabric of a building. So understanding that heat loss through the building means you can understand the heating requirement that needs to go in it and size the heating system accordingly. The test is also very fast. Like I said, it's carried out overnight. It's done in 12 hours or less. So it starts at sunset and finishes at sunrise the next morning. All that's made happen by the platform itself. That's predetermined and it starts automatically. And this means you can understand the heat loss through the building fabric, and the calculations can be used to gauge the heating requirement of the building, as I said. In terms of Veritherm monitoring, as I mentioned earlier, this is the other service we're able to provide shortly, coming later this year. So this is where we have in-use monitoring of heat loss and building performance. This is done sort of in contrast to testing. This is done when there's actually occupants in the building. So where residents remain in place, it could be something that goes on for a few weeks or months or just ongoing, but it's something that's discrete, it's left in situ, so it doesn't provide any kind of obstruction to the residents' day. And the results can be viewed remotely in real time on the cloud-based platform. So it's not a system where you have to go in and get the USB stick and download the data. It's all happening on the same platform as we would use on the testing system. Optional extras on this will be the ability to record other measurements, which will give you an indication of things like overheating risks, air quality, energy use, and mold and condensation risks. So in terms of why you might want to use the Veritherm monitoring over the testing, this would be the case if you wanted to understand the impact of occupant behaviour. It might also assist occupants in making energy savings, and energy savings, carbon emission savings, and financial savings as well. So by knowing what they're using, they're also more likely to change their own behaviour and make changes to carry on with those energy savings. You can use the building more efficiently. So there's the opportunity to make changes to how the equipment is commissioned. So it might be that equipment has been commissioned, it might not actually be functioning properly, but by monitoring over a period of time, you can actually see how well it is working. And by understanding the occupants' needs or occupants' use and the building's needs, it can give a longer term view with more information to put towards a plan for future renovation works. So just a bit of a summary then to show the difference between the Veritherm testing and the Veritherm monitoring. So in terms of Veritherm testing, why you might want to use that solution, it provides you with accurate data to understand total fabric heat loss. It provides a heating solution that's suitable for the needs of the building. Or it helps you with information that can help you with the heating solution suitable for the needs of the building. The times when you'd use it are when the building is unoccupied, and when fast results are needed. Like I say, it's just in a single night, but it does need to be a vacant property. The kinds of people that might want to carry out these tests are people like retrofit coordinators, heat pump engineers, energy assessors, and housing associations. So anybody that wants to really understand how well a building is performing as an empty, vacant building. In terms of Veritherm monitoring, why you might want to use it? Well, this would be to understand in-use building performance. So what's happening when the building is occupied and how the resident is using the building. And that can help them reduce energy bills, or using as other sensors, it can help improve the air quality for occupants as well. So this can be when the building is occupied, gives that longer term data if that is required. And there's many different kinds of people that want to use this as well, including people like homeowners for their own personal use. There might be social landlords who are looking at carrying out retrofit programs later on. Same with housing associations, and architects, energy assessors and heat pump engineers as well. So I will now just hand you over to Tom, and he will just take you through the dashboard and a bit of the reporting side of things.
Yeah, thanks for that, Lucy. So I just want to pick up on some of the points that Nathan has raised, as well as dive a little bit deeper into the information that Lucy's just given you there. So when we're looking at heating systems, the thermal quality of the envelope is a key factor in decision making. So you've probably all heard about U values and how we use those in the calculations for sizing and balancing heating systems. But understanding how a building is actually performing compared to those paper-based calculations can be very, very difficult. So this is where Veritherm comes in. And as Lucy has suggested, we've got a range of tools that can be applied at different times in different applications, so that you can select the right solution at the right time for your property. So what I'm going to do is I'm going to share my screen now and give you some insight into the software platform itself, so that you can look at some real world examples and some data to understand how that can actually influence some of your decisions. If you're looking at retrofitting a heat pump to an existing property, or whether you're looking at installing a low carbon heating system on a new development. So if I share my screen here, can you see that, guys? Nathan, can you see that? Yeah, fantastic. Okay, so the Veritherm platform itself is linked to all of the hardware and the smart sensors that we deploy within properties. It's a web-based application. It's entirely cloud-based, so all of the data is stored remotely, and you can view all of the data at any point in your measurement journey. As you can see here, we've got a selection of homes that have been tested using our system, and you can find all of the data that's stored on the platform and actually look in to all of the different examples that you've possibly tested across a period of time. So what I want to do is I want to start with a new build property where we have measured the fabric performance using our Veritherm testing solution, so that you can see just how difficult it is to understand exactly how that building is going to perform without integrating real world measurements of heat loss. So if we select this particular property here, this is a large new build property. And what we can see here is the measured value or thermal value for the entire property. So this is in units of watts per Kelvin. So this is the rate of heat loss per degree of temperature difference. So as Nathan mentioned before, that's what's required per degree of temperature difference. So the measured value on this particular property was 534.5. And we can break that down into where the losses are attributed to. So whether it's fabric, infiltration, ventilation, etc. What we can see from this particular property is all of the data has come into the platform. So we have internal temperatures, external temperatures, heating power that we've actually applied. So we apply a controlled and measured heat load to the property. And then what we can do is understand the building's response to that controlled and measured load, so that we can quantify the rate of heat loss. What you can then do is actually download pre-populated certificates and reports that house a load of information that's going to be really valuable when you're looking at your low carbon heating system. So if I download the full report for this particular property here, what you will see from the design information is the measured result is 534.5. However, what we have here is a breakdown of the heat losses in the building. So the total fabric heat loss for the building in the design was only 385 watts per Kelvin. So 385 watts per degree of temperature difference. The measured value is showing up quite a lot more than that. So we have a 57% performance gap with the building underperforming quite considerably. Now, what you need to consider is that when this low carbon heating system would have been sized, the U values would have been taken from the standardized tables and product data sheets, and your system would have actually been sized based on this design figure, when in fact the building needs possibly more energy to sustain a comfortable living environment, as we've suggested before. So as you can see here, there's a performance gap present, and if we enter into the property and allow it to become operational, then that's going to have huge impact on the efficiency and the overall performance of the heat pump that's been installed and the system as a whole. What the Veritherm platform also does is it provides a thermal efficiency rating for the property. So we divide the rate of heat loss per usable square meter of floor space in the property. So you can actually communicate to your clients how this particular property is performing on a similar scale to what you'd see on an EPC certificate, for example. So this kind of traffic light system is very, very easy for a client and end user to understand, and ultimately allows you to make some informed decisions whether the property needs fabric upgrades or you need to kind of review the design of the heating system that's going to be applied. With the Veritherm system as well, what you get is raw data plots per room. So as Lucy has suggested, we put smart sensors in each room of the property. And what you can actually do is look at all of the different rooms and see the heating and cooling curves for those rooms over the test period. Now, it doesn't give you a rate of heat loss per room, but what it does do is allows you to review sizing and balancing of heating emitters throughout the property. So a particular room might be showing a little bit cooler than others, so that when you're doing your heat loss calculations and you're sizing your heating emitters, you can actually consolidate your information against these raw data plots and see whether your assumptions are actually correct with where the cold spots are within the property. Now, if I go back to the main platform, what we've also done is measured a new build home, an existing home, as Nathan has suggested. So we've used one of Nathan's heating architects for this particular property. Now this goes the other way. So what you'll find is a common trend is that on new build properties, that there's an underperformance often present. And then on existing properties where we don't know what the thermal quality is, we tend to oversize and underestimate the thermal values of the property based on that unknown. So on this particular property, it was a 1920s large semi-detached London home. And if we download the full report here, or the certificate, sorry, what you'll find is that the predicted performance based on the heating calculation was 665 watts per Kelvin. So 665 watts per Kelvin per degree of temperature difference. And the measured value is actually 465.5, meaning that actually the building was performing 30% better than the heating engineer had expected. So what you could actually do on this occasion is review the heating calculation, the system installation, and actually specify a smaller unit for the property. So on this particular example, I think that there was a saving on the purchasing of the equipment. And then actually it gave confidence so that this particular customer could come off the gas grid entirely, meaning that there was an operational saving as well. So it just shows that paper-based calculations for heat loss are okay, but actually understanding exactly what the building needs and the requirements of the building is extremely difficult. And applying a real-world measurement to a particular building will give you clarity. It will allow you and your customer to make informed decisions based on real-world values, And there are also savings to be had with this type of approach. So we have now 2 low-cost solutions in Veritherm testing and Veritherm monitoring that can be applied to any property in the UK. And you can actually gather this real-world data on performance so that you can ultimately apply low-carbon heating systems that are going to be suitable long-term for buildings in general. So we are advocates for this approach. We're trying to make measurement mainstream, and we really feel that this type of system is going to support with mass rollout of heat pumps as we transition into the second half of this this period where we're looking to upscale renewables. So hopefully that's given you a brief insight into what you can do with Veritherm testing. As we said, we have a network of delivery partners that can offer this service anywhere in the UK. So we have testers in Northern Ireland, Scotland and England. And ultimately, we're looking for people to incorporate this type of approach and method into their practices so that we can ensure that heating systems are going to support our net zero ambitions. Ultimately, with the gas boilers that we've talked about, they have a bandwidth. So if they're oversized or undersized, it doesn't really matter. With heat pumps, it really does. And this type of system is going to support you and minimize risk. Because ultimately, if things go wrong, the heating engineer is almost always the first person that has the telephone call. So hopefully that's given you some really good insight. I'm going to open it up for a bit of a discussion now. So I'm going to unmute everybody. So if you do want to ask a question to myself, Nathan, and his colleagues or Lucy, then we'd really like you to hear your thoughts and see if we can answer any of your questions. So I'm just going to ask to unmute everybody. So you should have a request there. And if you do have any questions, then please let us know. Our details are there on that holding slide. So if you do want to get in touch or have a bit more of a bespoke run through of our services and our technologies, then please do get in touch and we'd be happy to help.
Shall I ask a question?
Oh, please do, Andrew. Yeah, carry on.
So just to clarify that the results you get are basically a whole house calculation. So even though you have the sensors in all the different rooms, you don't necessarily create a heat loss per room. It's a whole house heat loss.
Yeah, it's whole house heat loss. If you imagine we're applying a controlled and measured heat load to the entire property and circulating heat inside. So to understand heat loss from room to room is very difficult because there's no temperature differential present between the rooms. But what we can do, certainly with the testing solution, is give you insight into those raw data plots. So we split those down per room. And those heating and cooling curves are still very, very useful in terms of understanding how a particular room is performing when an applied heat load is put into that particular area of the property. So I think we've used the heating engineer calculations with Nathan, but what it does is it allows you to, it identifies the room that needs the largest heat input and breaks down the heating emitters. What we can then do is review those assumptions against the raw data plots, giving you a bit more confidence that you've balanced the heating system correctly based on that initial calculation. What we also do, I don't know if you saw there, is we divide the entire heat loss by the envelope area, and that gives you an average U value, so a heat loss per square meter of envelope. So you can actually input some data back into your heating calculations once that information is available from us.
Great. And just to clarify the relationship with MCS, because as I'm sure you know, MCS require a per room calculation. So what would MCS say if, you know, I guess we'd need the traditional heat calculation, you know.
Yeah, I don't think that we're ever trying to eradicate a heat calculation entirely. What we're just trying to do is improve the inputs so that you get a better outcome. So same goes with the SAP calculation for building compliance, same goes for a heat pump calculation. that still needs to happen. The Veritherm kind of technologies and systems will just improve the inputs of those calculations so that, you know, you've got a better view on actually what's happening.
Sure. And in terms of air changes, you had a figure on one of your things there saying, I don't know what it was, but do you estimate the air change loss?
There's two methods to this. So sometimes we'll carry out an air leakage assessment at the same time. So it allows us to break down losses with, you know, that are attributable to fabric, losses that are attributable to air leakage, etc. So it really does depend on to what degree you want to go to. If you just applied the Veritherm test, it would just give you the total losses. Plus an allowance for ventilation. Same goes for the monitoring system. If you apply other measurement solutions like an air leakage assessment, then you can break that down a little bit further. On the whole, we tend to carry out an air leakage assessment at the same time because it is useful information to have.
Yep. Thank you.
Great. Thank you, Andrew.
Great presentation, Tom. I really enjoyed it. I have a question about the hardware you used to collect the data. It sounded like you used smart plugs to collect temperature data from each room, and also I wasn't sure what you used to measure the power output of the boiler. And also, can you say a little bit about whether that's different at all for the Veritherm testing solution as it is for the Veritherm monitoring solution?
Yeah, okay, breaking that down. So if we start with the testing solution, Oliver, so the testing solution doesn't rely on the building's own heating system. We use our own electrical space heaters to heat up the building so that we can understand exactly the amount of energy that's being put in without kind of trying to contend with efficiencies with the boiler and so on and so forth. So the Veritherm testing solution uses an array of smart sensors that are remotely connected to the Veritherm dashboard that you have seen there. So the sensors are labeled up by room and gather temperature readings every minute for the duration of the overnight test. And we use power sensors to understand exactly what energy is put into the building. So they're connected to the heaters and the fans that are applied. And if there's any other electrical device inside the property that can't be terminated during the test, so whether that's a server or a refrigerator or something that we can't terminate, then we will apply a power sensor to that particular device so that that is incorporated into our calculations as well. With the monitoring solution, it's still in development. It's going to be released in the next couple of months, but just to give you a bit of an insight into how that works. There are temperature sensors again deployed in the property, a little bit less, and they're not deployed in every single room. We then use a gas or an electric consumption monitor that uses a certain frequency, and again that will be relayed back to the Veritherm dashboard so that we will incorporate the energy that's being used across the period of time, plus the temperature inside the property to then put through our calculation model to give you a result. So there's slightly different methodologies at slightly different times, but ultimately they're coming out with very similar applications, one contending with the occupant, the other obviously testing the empty property. Hopefully that's covered everything. Great, thank you, Oliver. Don't know if there's any questions for Nathan and the guys over there.
I've got a question, another question, if that's suitable.
Please do, Andrew. Yeah.
So, can you, with occupants, can you do this with occupants being in the house? I mean, does it have to be? How do you do the full house when you've got a house full of people?
So if you really can't get the occupant out or the property isn't vacant, then particularly you might use the longer term monitoring solution to get a view on the heat losses. The Veritherm system requires the property to be empty. Ultimately, people are a huge influence, and that variable is quite difficult to contend with when you're doing the rapid overnight test. But if you're going to monitor the property for a longer period of time, then we can, contend with occupants. So really, comes down to how quickly you need the data and what solution you require. Certainly for some properties that require a heat pump, so it might be a large property that is a 1920s home like the one that I showed you there, actually getting the property vacant for one evening is actually quite straightforward. And certainly if your client is going to spend a lot of money, then they tend to be quite happy to do that. So whether they're going to go camping or on holiday or stay with family, it's quite an easy process when you break it down. The monitoring solution is something that we're introducing because actually understanding heat losses long term is good. So you can keep that data feeding back to you and your clients, so that ultimately you can review what's happening on a monthly basis. So they're two very different applications, but very useful for different things, really.
Thank you.
Thank you. Fantastic. Nathan, I don't know if you've got any other bits that you want to add before we summarize and conclude today's session, but from myself and Lucy at Veritherm, I'd like to thank you very much for presenting. Really appreciate that. We've got another question coming in from Andrew. Andrew, you should be able to unmute yourself, but let me just send you.
Steve has got a couple of points after Andrew as well, Tom.
Yeah, fantastic. Okay, so I've asked to unmute you, Andrew, so you should have had a request there. So
yeah,
fantastic.
Can you hear me now?
Yeah, I can hear you.
Very good. I suppose this is for Nathan and Adam and co. Is there a halfway house between this system that you could apply, say, in your own home, where you could, monitor the heat loss? Say, if you were out for the evening, turn on the heat, turn it off at 6 o'clock, and then see what the heat loss was, see what the outdoor temperature, and get a more accurate calculation compared to a normal calculation.
I think that would blur it, wouldn't it? I don't know if I'd be sort of qualified to answer that question. If you watch some of the Heat Geek videos, I'll go into detail about not turning on and off your heating system anyway if you have a heat pump. Necessarily, you really want to aim for stable state heating. But regarding the actual calculation in this method, I've not come across it, so I haven't spent enough time thinking about it to give you a good quality answer. Sorry.
To bolster up the Veritherm method, what I've been doing for some time now is a watered down version of this. I'm sure the team there will be familiar with the Tiny Tag product, because where we are in Norfolk, we've got a lot of, as you say, 1920s, 1930s buildings, and very often there'll be a waterside building. We do a lot of water source installs in the area. But the other thing we've got is a very limited electricity infrastructure. So I've found that using proprietary heat loss software can often, you're overshooting, and heat pumps tend to be banded. So going up one size unnecessarily can often really be an adverse effect on how you're going to be able to get an electricity supply capable of supplying that heat pump, because you've got to allow for maximum output of that heat pump, the maximum load.
Yeah, I think in terms of the calculation,
that's really valuable, and to take it to the levels you have, this would really be a massive help towards those calculations.
Yeah, I think that's the point really, that we or our USP is that the proprietary algorithms that sit behind this software are slightly more advanced than you kind of trying to make a rough calculation by using what you've got. I think with heat loss, as Nathan suggested before, it's very complex. So there's lots of dynamic calculations in our model that can tend to make adjustments with certain elements and variables. So I think that kind of breaks heat losses down into something a little bit more accurate. And certainly if you're looking to do a quick heat loss assessment of your building rather than assessing it long term, it's certainly a very difficult process to actually get good data out of the other end once you've gathered it. So
could be a massive value to the end result. It really can.
Okay, brilliant. Hopefully that's answered your question, Andrew. Andy Frew from Northern Irish Housing Executive, I've got your hand up. So yeah, please fire away. I've asked to unmute you.
Yes, I'm just wondering about, can you correlate the results with, say, wind speeds to make them more accurate or to indicate that a house needs draft proofing?
Good question. What the platform does do is it pulls through weather data, so you can understand exactly what conditions the building was tested in, i.e. wind speeds, rain, precipitation, average temperatures, etc. Excessive winds actually means that the test can't happen, a bit like your standard blower door test. So if you've got consistent wind speeds above 30 miles per hour, that's going to significantly increase air changes and is something that our system can't contend with. But the good thing with the platform is its functionality. So we actually give the engineers a weather warning. So if there are going to be extreme conditions, then it can say perhaps, you know, take a measurement on a different evening and that type of thing. Increased air changes will obviously slightly change the impact of heat losses and the measurement. But research indicates that I think a 1 mile per hour change in wind speed probably changes our result by 0.1 or 2%. So we've managed to kind of robustly measure and assess that method to ensure that it can cope with those types of things. We do have a validation report, done some work with some independent research bodies and things. So if people are interested in some of the testing that's happened, to obviously get to the stage where we're at today, then obviously we can share that with you after the call as well.
Yeah, it's just that in terms of diagnostics, I used to do energy surveys, and sometimes the houses, you know, there are holes in houses that people don't know about that might be throwing your results off. Also in terms of stack effect.
Yeah, good question. And I think this is why quite often we carry out an air leakage assessment at the same time. So I'd say 9 times out of 10, a Veritherm test should happen alongside an air leakage test. With that, you can obviously do diagnostics and understand where there are holes and gaps and other things. We also have done other bits and pieces. And as you saw earlier with Lucy, we offer a range of services. So if you are wanting to do a full building health check rather than just a quick rapid assessment of heat loss, then we've packaged that up on several occasions where we'll do a thermographic survey, an air leakage test, a Veritherm test, so that ultimately you can understand exactly what state that building is in, and then report that back and make some decisions on if you need to, you know, rectify gaps and holes, as well as insulation, as well as other things like occupant behavior and so on. So we can offer those range of services. Veritherm isn't one size fits all, so you can introduce other building performance evaluation tools to get a better view on things, I think.
Is the pulse air test any good for you?
Pulse is good. Yeah, we know the guys at Build Test Solutions. We're working together at the moment, actually. So we're doing a lot of work together. So you can actually introduce the 4 PA rather than the 50 PA measurement into our dashboard. And it's actually a good way of understanding infiltration in a passive state rather than you know, ramping up the pressure inside the property. So the Veritherm solution will cope with both blower door and pulse methodology, and you can input that data onto our dashboard, and then we can disaggregate the losses based on those measurements as well. Fantastic. Thank you, Andy. Anybody else before we round up? Brilliant. Well, hopefully it's been an insightful session for you all today, and you can understand kind of what's out there with regards to emerging technologies that can support with large-scale rollout of low-carbon heating systems. I'd like to thank Nathan and his colleagues for joining us today and giving us some useful tips and pointers on heat pumps and systems. And thank you to our own Lucy Cowell for giving you some insight into our business and the types of things that we're working on at the moment. I'd urge you all to get in touch if you'd like to learn more and see if you can integrate this type of product and service into your practices, whether you're a heating engineer, a stock owner, a developer. This type of stuff will really help with long-term decarbonisation strategy. And yeah, thank you very much for giving us your Friday morning. Enjoy your weekend, and we hope to hear from you all soon. Thank you very much. Thanks, guys.
Thank you.